Okay. Honorable judges and respected audience, good afternoon. We are Empat Srikandi of Sebelas Maret University. We are consist of Hanifa, Sarah, Yuki, and Robawati, and guided by Dr. Farida Nurhasanah as our advisor. We are proud to present our STEAM stories and innovation about balancing clown in the next slide. And in the next slide, we can see that this is the story about Sri. It all started with curious and cheerful girl named Sri.
Hello everyone, I'm Sri. One day, my parents and I went to a circus show. We saw various attractions there. That day, one show really caught my attention. I saw a clown moving on a unicycle along a rope. That clown was so great at riding the unicycle, but the clown movement was very wobbly. It almost fell over and over. I wish I could help the clown. Suddenly, an idea came through my mind. I wondered if I could make something similar to the clown attraction. After coming home, I grabbed my pencil and a piece of paper to write my idea about the clown that can cross from one point to the other.
Okay, based on that problem in this story, the balancing clown was complete using the EDP engineering design process method with three main issues: is that motion dimension, balance, and direction. Balancing clown has 5 main parts, namely tower, bridge, pulley, unicycle, and clown's body. It's like in this picture, and it all made with 4D frame. In the next slide, we can see that balancing clown has dimension as shown. We can see that the dimension is have a length and width like that. And the next slide, let's talk about the towers and bridge. The towers and bridge we can see in this slide, and the next slide, this is the bridge of balancing clown. It makes by 2 flat pot question mark hook and double question mark hook. Each double question mark hook is placed at distance of 5 centimeters based on this situation. We can see that the first term is 2 and the difference is 2. The equation of the arithmetic series becomes 2n. And the next slide, we can see the tower. The tower in here, we have 2 bridges to support the right and left side. And the next slide, we can see that this is the stage building of balancing clown tower. The steps of making the tower include mathematical analysis in terms of the space and plane diagonal. The diagonal plane in one part of the tower is 5 square root 2, while the space diagonal is 5 square root 3. This is the pulley, so we can see this is the pulley used to make the clown to go back and forth. This is the pulley uses various body frames and use good like cardboard, bottle caps, and wires. So if we can use some mathematically analysis, this pulley has a belt system that binds the pulley A and B to have the same direction, linear velocity, and angular velocity. In addition, the maximum distance as a clown can travel in one round can determine through the circle circumference formula. The pull length that can reach is 9.42 centimeters. So in the next slide, we can see that this is to strengthen the pulley structure. We reinforced it with addition design as shown in this picture. So let's talk about the clown. This clown have a head, arms, and leg with 3 steps to pull. So from that, then we have the spare unicycle. It's equipped with hooks on the right and left side. This hook is used to connect the unicycle to the ribbon. So we can see the next slide, the clown will be linked with the unicycle. In this balancing clown, we are also using the hanging meshes to make the balancing clown balance during the back and forth. This balance consists of 2 concepts, is that inverted pendulum, hanging meshes, and this inverted pendulum means that the clown has the center of meshes above the pivot point. It also means that the hanging meshes give us 0.006 Newton of weight. I think that's all. Thank you. You can see that this is our project result in this video.
네, 실제 작동 영상을 보고 발표를 마치도록 할게요.
Can you put, oh,
Okay. Sorry, can you replay the
네,
question? Sorry.
잘 봤습니다.
thank you. Thank you for your presentation.
자, 예, 이제 질문 드리겠습니다.
So we'll have a few questions for your project.
네, 네, 첫 번째 질문입니다. 이
First
프로젝트는 누구를 대상으로 생각하면서 제작하였습니까?
So the first question is, who do you think is the appropriate target age level or school year for your project?
So let's
Okay.
begin. Let my friends answer this question. So Sarah, take your time.
Okay, thank you for the question. I think the appropriate age for this project is around junior high school age, around maybe 12 to 14 years old, around that age maybe.
중학생 나이인 12세에서 14세 정도로 생각하고 있습니다.
네. 두 번째 질문 드리겠습니다. 이 타워나 브릿지 부분을 좀 더 튼튼하게 제작할 수 있는 방법이 있을 것 같은데요. 혹시 고민해 보지 않았나요?
So the second question is, there seems to be a way to make the bridge or the tower a little more stable or stronger. Have you ever thought about another way to make them?
So let me answer this question. So we make to strengthen this structure. We are using the hanging mess first. First, we are use the hanging mess. There are two hanging mess in right and left, and then we are using some ribbon. That we have to ribbon in the right and left. So it will be connected to the unicycle. It will make to more stable if the clone forward and backward.
목소리가 정확하게 끊겨가지고 잘은 안 들리는데 아마
네.
행잉 메스를 지금 달았는데 리본을 연결을 하면 좀 더 튼튼하게 만들 수
일단 저도 그렇게 이해는 했습니다. 자, 세 번째 질문 드리겠습니다. 이 클론이 아무래도 이게 흔들리면서 불안한데 얘를 무게중심을 잡아주던가 하면서 좀 흔들리지 않을 수 있는 그런 방법이 분명히 있었을 것 같은데 그거는 고민하지 않았는지 궁금합니다.
So the third question is, so the clown seems to moving back and forth, looks a little unstable. Have you ever thought about a way to make it more stable, and then maybe you could have some sort of a way to get the center of mass to be not as moving? Have you ever thought about that? Hello, did you guys hear my question?
Oh, sorry. I mute my account. Okay. So I will answer this one. So to make it more stable, we can use two more mess in that. So we just use 6 gram in one mess. So we can put a lot of mess, more than 6 gram. I think like that. And because we have the system like inverted pendulum, we can say the mass of unicycle, we can build more of mass. Like we can add more like 4 different figures. It can, so if we make bigger, this product. We can make it have more masses like that. So the unicycle will have the bigger masses, and also the hanging mesh will have the bigger masses. And of course, we have belt pulley belt system. This pulley belt system, we should have the ribbon with tight pulling like that. If the tight pulling, it will more stable like that. I think that's some addition for me.
Thank you. 행잉 메스 6g을 사용했는데 더 그 메스를 6g 이상으로 더 추가할 수 있는 방법이 있고 또 그리고 그 클라운 자체를 더 크게 만들면 좀 더 낫지 않을까라는 생각도 했고, 그리고 유니사이클에 리본을 묶으면 좀 더
안정적일 수 있다. 예.
네, 안정적일 수 있다. 그렇게.
예.
네.
발표 잘 들었습니다. 수고했다고 전해드리고 싶습니다.
Thank you for your time and effort for your project.
Thank you.